Okay, fine. So, welcome you all in this webinar organized by the Department of Applied Sciences and Humanities with a particular aim and introduce you all to new technologies that has changed our perception towards the construction of houses, buildings, and bridges and other infrastructure where billions of dollars are being used up to assure the safety and the life of our infrastructure. As such, earthquake resistant structures are being preferred. So earthquake engineering is the ultimate challenge for structural engineers. Even if natural phenomena involve great uncertainties, structural engineers need to design buildings, bridges, and dams capable of resisting the destructive forces produced by them. These disasters have created a new awareness about the disaster preparedness and mitigation. Before a building utility system or transportation is built, engineers spend a great deal of time analyzing those structures to make sure that will perform reliably under seismic and other loads. The purpose of this webinar is to provide structural engineers with tools and information to improve current building and bridge design and construction practices and enhance their sustainability during and after seismic events. Earthquake-resistant surfaces feature seismic designs and retrofitting techniques for low and high-rise buildings, single and multiple span buildings, bridges, dams, and nuclear facilities. So today we have with us Engineer Mueed Rasool, Assistant Executive Engineer in the Department of Public Health Engineering. Engineer Mueed Rasool has got expertise in the field of structural engineering and seismic safety of structures. And I'm very much sure that this session is going to benefit you a lot. I request Engineer Mueed Rasool to share his expertise with our students. So please, mic is with you. Wait a minute. Okay, sir. Sir, mic is with you?
Okay, fine. Are you getting me?
Yes, yes, sir. Mic is with you?
Yeah, my kids with me.
सर आवाज थोड़ी सी कम आ रही है.
I will increase my tone.
Sir, you can share your screen.
Wait. I'm just
Yes, yes, sir. Yes, sir.
uploading
Yes, sir.
my presentation.
It's fine.
Okay, thank you. Yeah, are you getting
Yes, sir. Yes, sir.
the PPT?
Yes, yes. It's fine. It's fine.
The font is okay.
It's okay, but voice is a bit slow. Voice थोड़ी सी low है.
Wait for a moment. Voice is low. Now the font I think has got now better.
Yes, yes, sir.
Okay.
Yes, yes, it's fine.
Oh, shall I start?
Yes, yes, sir. You can start.
Okay, fine. Thank you for giving me an
Thank you.
opportunity
Thank
to
you, sir.
start
Thank
this
you, sir.
topic
I will
on the
mute
physics.
myself.
Yeah, so just wait.
I will
For
mute
giving me
myself.
opportunity
Okay,
to
sir. Okay, fine. You can start.
just wait for a moment. So I am thankful to all for giving me the time for presenting my topic on the seismic safety of structures. And myself, I am Muid Rasool. Presently, I'm a structural engineer and working as an assistant executive engineer in the Public Health Engineering Department, Kashmir. So my specialization that's about the earthquake safety of structures. Presently, I am going to give a presentation on the seismic safety of structures. Okay, shall I start?
Yes, sir. Yes, sir. You can start. You can start. You are
Okay, I
visible
will
and audio
continue.
is also clear. Thank you, sir. Thank you, sir.
Okay, 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 fine. So basically, if we look on the structures in the Kashmir Valley that lies in the zone 5, we have to take a proper precautions while designing the structures for the earthquake forces. So what basically is the earthquake? What are its types? So that is very important before going in detail. So first, there's an earthquake. We know when there is a sudden shaking in the ground, in the earth, we say that it's an earthquake. That ground shaking may be due to bomb blast, it can be due to landslide, it can be due to volcanic eruptions. So anything which can disturb the motion, which can disturb the orientation of the earth and can cause, a disturbance in the mind of a person. So we treat that as an earthquake. So if we look on the past earthquakes, the devastating earthquake, because whenever you have to design any structure, it is very important that you have to, study the past earthquakes to see what is the past history of various earthquakes, because we are never going to know what will be the future earthquake. So what we do, we basically study the past earthquake, we see the past trend, and past experience gives us the techniques, the trends, what we have to apply in the future structures. Okay. Now, first, I am basically discussing about the Chichi earthquake, which has caused a great devastation in the year 1999, due to which various structures have collapsed. The reason was they were not the engineering structures, and they were designed, by the local engineers or not by the structural engineers. Second thing is the earthquake, which was a biggest devastating earthquake in the history, was the Kobe earthquake in 1995. This earthquake, it not only damages the structure, but it causes a great damage to the transportation system. If you are riding your vehicle or you are on ship, you are on aeroplane, landing or somewhere, so once the earthquake occurs, it can cause a great damage during your driving to the persons who are sitting inside. So Cube earthquake, that was also a great experience. That was a great lesson for us to study the earthquake in detail and make our future structures safe for the earthquake. So these are just pictures which I'm going to show here to show what the earthquake basically causes. And it basically will increase your interest in the topic, in the present topic. Fine, not only the buildings, but bridge. There are two structures which are considered as important in the earthquake. Number one, there's a hospital. Number second is the bridge. So what happened basically during an earthquake, when there's a casualties, people get injured, we have to shift them to the nearby hospital. So we are going to shift them to the nearby hospital by way through a road having the bridge. But when your bridge will collapse or the hospital which will collapse, there will be more casualties because you are not going to get the treatment of those injured persons or the casualties. So collapse of bridge or a hospital, that will cause a great devastating. So those structures, that is a hospital and bridge, have been considered under the category of important structures. So we have to give a due importance while designing the earthquake. Now, if you see, at various places, instead of earthquake, we are using the seismic forces, seismic activities. So the whole term have been derived from the science, that's the seismology. Seismology is basically the science which deals with the study of earthquake, find how earthquake occurs, its types, and all these things. So again, I am going to explain about the focus of the earthquake. The center of the earthquake is called focus of earthquake. We have the earth. At some point, there will be origin for an earthquake, where the earthquake inside the earth will occur. That is called as the focus. It is just like the lenses hanging the focus. Same in case of earthquake, there is some original point, some origin inside the earth, which we call as a focus. And just at the top of that point, on the surface of earth, that is the epicenter. So the distance between the focus and the epicenter, a distance will be between them. We call that as a focal depth. So basically, these earthquake forces, seismic waves, they are basically the elastic waves, and they change their response from the longitudinal to reflection. All these properties these waves have, and we have to study these waves, those earthquake forces in detail before we are going to impose them on our structure. So focus, already epicenter, I have described to you, shock waves. And you can see here, this photograph will give you more representation regarding the focus. Basically, if we look on this point, there's the origin of an earthquake. We call that as a focus. And at the top of this is the epicenter. And distance between this focus and epicenter, there's a focal depth. So please mind it and keep in memory. So now, how the earthquake occurs. There are some, weak planes in the surface of the earth. By pictorial, you can see we have some weak faults in the surface of the earth. What happens? The sliding, once these two plates get mobilized, there is just a drift down of these two plates. One gets up, another gets down. So due to that, once mobilization occurs, slip failure occurs, there is a wave gets generated. That wave gets transferred to the whole earth or to some particular area, and that causes the earthquake or sudden shaking of the earth. Now we have the two terms which we need to explain. There's the magnitude and another is the intensity. So magnitude, basically is calculated as per the Richter scale, and we calculate the magnitude as per the log scale, log 10E equal to 11.4 plus 1.5 M. So M is the magnitude, and we have proper classification for the magnitude. So proper scale, there's a Richter scale that gives different values of the magnitude 1, 2, 3, 4. And when there is a very devastating earthquake, when there's a large earthquake, remember the point, when there's a large earthquake, we say its magnitude is high. And when the value is low, say 1, 2, or 3, magnitude is low, fine. But it never gives indication that the higher magnitude can cause more damage. It's not necessary. I will give a bit example of if a magnitude of earthquake of magnitude 5 will occur in Srinagar, in Lal Chowk, and the higher earthquake of magnitude 7 will occur in Kargil. Fine, in Lal Chowk, suppose, or in Srinagar, the magnitude of 5 earthquake will occur, and at some other place like in Kargil, some 7 magnitude of earthquake will occur. You know what? Basically, the damage, the 5 magnitude earthquake can cause tremendous damage as compared to the 7 in Kargil, because 5 is occurring in that area where the density of population is high. Fine, number of people can die. So never keep this thing in mind that there is high magnitude, it can cause more damage, and there is low magnitude, it can cause low damage. Not necessary. There maybe it's based on the area where it is basically occurring. Fine. So I will continue with this. So what basically this magnitude indicates is basically indicated the energy, what the earthquake energy is releasing. Okay, because when there is disturbances, when waves are produced, shock waves are produced due to earthquake, definitely it is associated with the energy. And on the base of energy, we can calculate, our magnitude, or on the base of experience, we can say this is the earthquake of this magnitude. But higher magnitude can cause low damage, lower magnitude can cause high damage. So magnitude never explains, never indicates that devastating more. Fine. So what is basically the term which indicates that damage is more? That's the intensity. Fine. So again, I'm repeating the example of the Lal Chowk where the earthquake of 5 magnitude has occurred. Fine. And in Kargil, the magnitude of 9 or 8 has occurred. The damage will be more in Lal Chowk. So we can say the intensity of earthquake is more in Lal Chowk as compared to Kargil. Fine, having the different magnitudes. So intensity is basically the scale that's damage. High intensity means the high damage, and low intensity means the low damage. Low intensity means some cracks have occurred in the building, normal fault is this, but when there is a high intensity, it means total collapse of structures, death of peoples, all these. So whenever you have to use the term, please use them properly. Now, we have basically the classification of the earthquake as shallow, intermediate, and deep earthquake. Again, I have already explained the focal depth. If your focal depth is less than 70, you can consider it under the category of shallow earthquake. And when the value is between 70 to 300, it is intermediate earthquake. And when the focal depth is more than 300, it is considered as a deep earthquake. Fine, means earthquake has occurred from a large depth. Fine. Again, there are various waves which are associated with earthquake. One is a P wave and S wave. When earthquake occurs first, these are the P waves that we call as primary waves. They occur first. They give us indication that earthquake has occurred. Either if you are in sleep, deep sleep, we get up. And when there are S waves, these are secondary. Means after P waves, S waves occur. And these S, that's the secondary waves, they cause a great damage. So P waves, they are longitudinal compression, rarefaction. They are first which occur. Then there are S waves. You know, S waves are they are the great power. They create great damage. That is why after just getting a shake, this is the second primary waves, and after a few times when S waves occurs, they start causing damage to the structures. Now, classification of the earthquake has been also made on the magnitude of Richter scale. When your magnitude is 4.9, it is a slight earthquake. When it is 5 to 6.9, it is moderate. When it is 7 to 7.9, it is great. And when it is 8 and more, it is very great. But again, this moderate earthquake doesn't mean it will cause less damage than this very great earthquake. Not necessary. Basically, this is occurring on some particular area. So when the earthquake occurs of any magnitude, you have to see the area, whether it is occur in high dense population or it is occur in less dense population. It is same as you are, suppose a person is throwing the grenade in the Lal Chowk, that grenade will cause more damage in Lal Chowk. Same, if the said person will presently throw some grenade in some garden which are closed, it will not cause. Even if you throw 3 grenades at a time, it will cause it will release more energy, but losses will be less because density presently in the garden is very, very less. Nobody is entering. Fine. So this is this example what I am showing here. So one of the important example for the earthquake, that is a tectonic. It is a very important example. What basically the earthquake occurs? Why in Himalayan regions? Because we in Kashmir Valley, we are under the zone 5. Why it is under zone 5? Why the Jammu region is under the zone 4? Or in some area, the zone value gets decreased. Zone 5, in the Kashmir Valley has been considered as, most vulnerable to earthquake. Earthquake can occur here more, and they can cause great devastating, in the area. So what tectonic basically, inside the earth, we have the crust surface, or mantle. Fine. When we look on the earth, we have various continents. Those continents, basically they try to get shift. Okay, there's a drift of continents. And due to drift, 2 continents are, striking with each other. Definitely when a heavier mass is striking with another mass, definitely it will cause some striking effect. So that striking effect basically causes fold in the, mantle or in the stone profile inside the surface of Earth, because inside the surface of Earth there is a proper stone layer, big large stone layer, and those stone layers they get basically compressed due to the striking of 2 plates. So once striking occurs between 2 plates, energy gets generated, and that energy causes folds, some sort of bends in the surface of stone, and due to that bends, the large Himalayas have occurred. It is basically the history which tells. So when these folds have occurred, Himalayas have occurred, what basically this earthquake causes, our stone layer, that is an inelastic material. Inelastic means it will not show so much of deformation. Okay, it will show the deformation up to some limit, but once the striking continues, okay, the energy gets generated inside the rock surface, and once extra energy gets stored inside the rock surface, a time reaches when the rock breaks, and once the rock breaks, the tremendous amount of energy gets released, and there is the rebonding of these two cracked rock surfaces. Rebonding occurs, fine, rebound sort of. So when rebounding occurs between the two surfaces, it generates a large energy, large shock wave, and that gives a striking or the sliding effect to the Earth's surface, shaking effect to the Earth's surface, and you say, okay, earthquake has occurred. Fine. So that was basically the striking of rock surface, and we consider it under the category of elastic rebound theory. Just like you are waiting for a striker on a carom board, a time reaches when you release your finger. The finger force gets transferred to the striker, and that striker starts rebounding here and there. Same occurs in the rock surfaces. Energy gets released, it reaches up to some point, then where this is transferred, and this causes striking of the rock surface, and that basically causes a great energy release of energy, a great vibration, great shocking, and that has been considered under the category of tectonic earthquake. Okay, the simple example is I have a scale in my hand. I am applying pressure on the scale. A time will reach when the scale will break, glass scale will break, and two hands will move just like this. Okay, there will be sliding or there will be shaking, and shaking, my body will get shivered, or my body, there will be vibration in my body. Same is with the earth also. Vibration gets generated, and once vibration gets generated, it produces a earthquake effect. Now, what are the techniques? We have the masonry structures in the Kashmir Valley. We have the framed structures now. High-rise buildings are there, but preference should be given for the safety. Never be after the architectural view. Sometimes there are limitations. Okay, architect will say, no, we'll place a glass on this side, that side. We will make glassy house all around. But we have to be cautious about the strength of material. We have to be cautious about the strength of materials. That is very important. And for that, there are some techniques by which we can make our structure safe for earthquake. First, we have the normal walls which are constructed in residential houses. What we basically, after one wall or two walls, we place the horizontal bars. These horizontal bars give strength to these walls. How? Later on I will explain. So these are the horizontal bars, and these are the plan of these horizontal bars, how we place the horizontal bars in the masonry or in concrete structure. Okay, here also you can see these are the bricks where the vertical rod has been placed. So two things I have applied here, horizontal bars and vertical bars. What happens basically? What happens if you are without these vertical bars and there is no lintel band or there is no horizontal band in the structure? What happens? The cracking of wall may occur during an earthquake. And instead of that, what we basically do, we have the structure, where we provide the horizontal bands or horizontal reinforcement, horizontal steel bars, vertical steel bars. It basically makes the structure compact. Our four walls, they are in contact with each other, and once the earthquake force will occur, the structure will behave, as a single unit. In the above mentioned, these three structures, they will not behave as a single unit. They will start collapsing separately. But in the fourth case, where we are applying proper techniques, proper reinforcement, proper horizontal reinforcement, these bars will be in contact with each other, and due to which our structure will behave as a single unit. All four walls will be in close contact with each other, and during earthquake, they will behave as a single wall, just like a box, and your structure will be safe for the earthquake. This is a minor example how we can make our residential structure, our simple structure, safe for the earthquakes. And we call that box action. Okay, when the structure has been provided with the horizontal reinforcement, vertical reinforcement, we call that as a box action or the diaphragm action. And this diaphragm action makes our structure safe. Now, in various places, what we go for the Daji Diwars. Daji Diwars, maybe you have seen in the old structure during an earthquake in the ODI, I have seen a number of structures which have now collapsed, and a new structure who have got collapsed. What basically in the past, because there was some application of engineering during the Mughals, they were using the engineering techniques, they were using proper bracings, vertical bracings, horizontal bracings, lateral bracings, and that also makes this structure a box type structure. And after that, they go for the clothing. They fill up with the bricks, and during an earthquake, the whole structure behaves like a single structure as a box and show diaphragm action. And these type of structures, they resist the earthquake up to some limit, because there's a limit to everything. Fine. So this is just example of these bracings structures which resist the earthquake during an earthquake. So these are all structures. Say your wall has collapsed, but overall the structure is safe. These are minor structures, but if we look on the new structure, this is again how safety has been provided. And second thing is that in the old days, we are going for the base isolation. Later on, I will explain in detail the base isolation techniques. But presently, what the people in the old days were using, they were making a proper, foundation, and they were using the pile foundation, strips, they were using bolt connections. This basically reduces the earthquake force because you are in less contact with the ground surface, less forces, or the forces get damped during a sudden shaking of an earthquake, the earth. This is again the base isolation where the planks have been provided in the foundation, and due to these planks, our structure that becomes safe because it damps the oscillation. It basically reduces the energy of an earthquake. That energy gets wasted while compressing, while showing the shock waves to the wooden surface. So wooden will you basically show some deformations, and the energy of an earthquake will get reduced. Fine. Once the earthquake energy will get reduced, your will be safe. So foundation techniques we can apply. Now, what basically presently in the new structures, we have various categories of retrofitting, how to make a structure safe. One is the conventional, and second is the non-conventional methods. What basically conventional means, there are two techniques. Either you will make your structure safe for an earthquake by giving it more and more strength, or there's a different technique. What you can do, you can reduce the earthquake force. Structure is same at its own place. No strength has been added to the structure, but the forces, the forces gets reduced. We can reduce the force. So two techniques, conventional. In conventional, we make our structure strong to resist earthquake. In non-conventional, we reduce earthquake forces and keep our structure same. So in both conditions, we are basically preventing our structure from the collapse. So here we have various techniques in the conventional method. That is, first technique is the adding shear walls. We have adding steel bracing, infill walls, concrete jacketing we have. And in the second technique, where I told you that we will reduce the earthquake forces, fine. Once we will reduce the earthquake force, how we can reduce? There is different techniques. One that is a seismic base isolation. Another is the supplement damping devices, which we are using. What basically, when an earthquake occurs, it has some demand. It demands your structure should be safe for this much of energy. And if your structure doesn't meet that demand, or the structure doesn't have the capacity to meet that demand, your structure will collapse. So in the conventional method, what we do, we increase the capacity of the structure. We use strength, we retrofit our structure and increase this, strength, and that we call as a conventional method. Fine, we are basically increasing structural strength. And in non-conventional method, what we do, we reduce the earthquake forces. We reduce the demand. The demand is reduced to up to that limit, which will not cause damage to my existing structure. Fine. So this is the capacity and demand. Demand earthquake क्या है, और वहां से capacity structure की कितनी है. तो पहले मेथड में, कन्वेंशनल मेथड में मैंने स्ट्रक्चर की कैपेसिटी बढ़ा दी और वो सेफ हो गया, और कुछ वैसा ही है. दूसरी टेक्निक में मैं स्ट्रक्चर की और कुछ की कैपेसिटी रिड्यूस कर रहा हूं और स्ट्रक्चर की
Hello, sir. Sir, am I audible? Hello, sir. सर कुछ शायद डिस्कनेक्ट हो गया, थोड़ा वेट करते हैं. ओके माय डियर स्टूडेंट, सर को डिस्कनेक्ट हुआ था, फिर से ही विल ज्वाइन इन अ व्हाइल। बस थोड़ा सा वेट करें आप लोग, बस थोड़ा सा टाइम लगेगा। तब तक आप जिसको कुछ क्वेश्चन पूछना हो बीच में, वो अपना हैंड रेज कर सकता है, ठीक है। और प्रेजेंटेशन के बाद भी आप अपना क्वेश्चन डाल सकते हो, ठीक है। तो हर एक को टर्न मिल सकता है क्वेश्चन पूछने के लिए। फाइन, तो सर का थोड़ा वेट करते हैं। ओके स्टूडेंट्स, आप अपना क्वेश्चन रख सकते हो चैट बॉक्स में। जब तक सर वापस रिकनेक्ट हो जाए, आप अपना क्वेश्चन चैट बॉक्स में रख सकते हैं। फाइन, किसी को कुछ पूछना है वो चैट बॉक्स में अपना क्वेश्चन डाल सकता है, ठीक है। तो जब तक सर वापस ज्वाइन ना करें, write your question in the chat box. ओके वेरी नाइस, तो यहाँ से मुझे कुछ मिल रहा है। ओके फाइन फाइन, वेरी नाइस। ओके ओके, गुड गुड, आई विल टेक these questions definitely, sure. I will take these questions for sure. We can an audio method. सर को डिस्कनेक्ट हो गया। जब कॉलेज खुलेगा तो तब हम डेफिनेटली ये वेबिनार हम फिर से स्टार्ट करेंगे, ठीक है। तो आपको पता है 2G का मसला है, वरना ये प्रॉब्लम नहीं हुई होती। फाइन, तो इंशाल्लाह जब कॉलेज फिर से खुल जाएंगे तो तब हम ये प्रेजेंटेशन फिर से करेंगे, ठीक है। तो थोड़ा सा हम सर का वेट करते हैं, क्योंकि सर इज एक्सपर्ट ऑन दिस प्रेजेंटेशन। फाइन, तो उसके बाद आप अपना क्वेश्चन डाल सकते हो। सर को रिकनेक्ट करने से पहले आप अपना क्वेश्चन डाल सकते हो, फिर हम सर से वो क्वेश्चन पूछ सकते हैं। ओके सर, थैंक यू सो मच, you got connected again. Thank you so much. Okay sir, you can start,
Fine, fine. Screen sharing enable, please. Enable screen sharing.
Okay sir, okay sir. Is it fine sir?
Yeah, it's fine.
Okay sir. Okay sir, please continue your presentation.
Okay, fine. I think we got connected now.
Okay, yes sir, here we have got many questions, but until sir will not finish his presentation. आपका क्वेश्चन तब हम लेंगे प्रेजेंटेशन के बाद. फाइन, तो आप ऐसे क्वेश्चन वेरी नाइस. तो बहुत सारे क्वेश्चंस भी हमें मिल रहे हैं, तो हम इसको ले सकते हैं. सर हम एक क्वेश्चन ले सकते हैं?
Yeah, I will first conclude my topic.
Okay, definitely, fine. Okay, sir, you conclude your presentation.
So I was basically at the conventional methods. In the conventional method, we have the shear walls, because this is the whole, the family of an earthquake, which we are basically here, the components of an earthquake, all these things. So once, if you get aware about these things, your interest towards an earthquake will increase, and you can give some better suggestions and some better recommendation than me. So I will continue. Fine. Okay. So basically, we are adding shear walls. What basically, I will show a pictorial view of a STAT model where we have added a shear wall to our structure. What basically this shear wall does, it increases the structural stiffness of an earthquake. So when your earthquake will come in axial direction, these two shear walls, they will resist that. Okay, fine. They will give a great strength to the structure, and our structure will not collapse. So that was basically the. So what it basically does, when earthquake forces come, and these are resisted by these shear walls. So how they resisted by their own shear strength, they transfer it to the foundation, and they prevent the sliding of an structure. But what basically why shear walls are less used in present days? Reason
sir,
is that
excuse me for a second, sir. Sir, excuse me for a minute. डियर स्टूडेंट्स, अब ये क्वेश्चन की बम्बार्डमेंट है ना, आप ऐसे मत डालो, ठीक है? तो थोड़ा डिस्कनेक्ट हो गया था, तो इससे प्रॉब्लम हो जाती है सर को प्रेजेंटेशन देने में, ठीक है? अब बस क्वेश्चन ऐसे ही रखो, जब प्रेजेंटेशन खत्म हो जाएगी आई विल टेक वन बाय वन. फाइन, अब आप क्वेश्चन मत डालो चैट बॉक्स में, क्वेश्चंस मिले बहुत सारे. ओके सर, यू कैन कंटिन्यू योर प्रेजेंटेशन.
In case if they will not get time, I will not get time to reply to the questions, give them my contact number, and later on they can talk to me, patiently, and they can ask any question regarding earthquake. Maybe I don't want to skip any question. I don't nobody should get this, please. Okay, so basically these shear walls, they resist the earthquake. But what happens if you are adding your shear wall to an existing earthquake? Large force gets generated, and these forces get transferred to the foundation. If your existing foundation is not strong, your structure will collapse. So बिल्डिंग को रेजिस्ट करता है, लेकिन पुरानी बिल्डिंग को रेजिस्ट किया, लेकिन पुरानी बिल्डिंग की जो फाउंडेशन है ना, वो फेल हो सकती हैं. इट इज सेम कि हम किसी ओल्ड पर्सन को ऊपर से दस्तार वस्तार पहनते हैं, ठीक है, लाइक दैट, तो स्टिल दैट इज ओल्ड. इसीलिए इसकी स्ट्रेंथ बिल्डिंग की, बाय एडिंग द shear wall, it will increase it, but foundation problems arises. Okay, my building may collapse. So using shear walls is not a better solution in the existing structures. However, in new structures you can add, you can calculate the forces, you can transfer them to foundation, then you can design your foundation for those forces such that your structure will be safe for an earthquake. So you can see the shear failure which has occurred in the these shear walls. So this is again the reinforcement. There's a haphazard reinforcement in case of shear walls. Opening gets closed. That also creates a great hindrance while we move from one place to other place, or we have to move from one room to another room. Various openings, those gets closed due to the shear walls. That's why we doesn't prefer these shear walls in an existing structure for retrofitting. However, in new structure you can design your foundation, you can use shear walls because it will be safe. Second thing is that location of shear wall. You can add at the center of wall, you can use shear wall. At the corners, you can use shear walls, L type of shear walls. All these things are available. So this is the building, new constructed building, where already shear walls have been provided. You can see the vertical shear walls. And we don't have a problem because it has been designed by taking into consideration the forces which get generated during an earthquake to the shear walls. Because shear wall will take the force, it will resist, it will make the building strong, but that forces will get transferred to the foundation, and we can design our foundation in a new structure. So for new structures, it is a good, a good solution to make it earthquake resistant, but not for the old structures like hospitals. We have a hospital here, GFP1 hospital, that is also deficit, and that may collapse during earthquake. My presentation was about that, and I have calculated various techniques. I applied the shear wall to the building, but what I got from the calculations that my foundation is getting failed. The GP1 hospital gets failed if we use shear wall. The building is safe, but foundation failure. Foundation failure means the whole structure will collapse. Okay, so I have not implemented this technique of shear wall to the GT1 hospital because there's only one children hospital in Kashmir Valley. So we have to take proper precautions, being the most important structure for children. Okay, then we have the second how there is the horizontal forces. When the earthquake horizontal forces came, they show the truss action, and those truss actions prevented the lateral drift of structure. They prevent the collapse of structure. However, again, in old structures, whose columns have not been designed for the axial forces which get transferred due to earthquake. Okay, so what we do in new structures, we can go for the bracing system, but in old structure, bracing system is not good. Fine. This is again the bracing system techniques which can applied in the building, which is basically the shake table test, where we are basically testing the model by using these bracings, that how much forces in the column will get reduced by using these bracings. And definitely, if you have seen in the truss, if we are adding members, forces in the member get reduced. Members become safe. But when the axial forces at the corners, they get generated and they get transferred to the column, and our column can show the lateral, failure or shear failure, sliding horizontal type of failure, because they are weak columns. So for new building, it is good, but not for the existing structures. So this is a bridge. In the bridge, we are also using these techniques of lateral bracings in the trusses and all these things, because forces get transferred, wind reactions, all these get, transferred to the structure safely by using bracings, and these bracings prevent our collapse of structure. So this is the bracings, how your wall behaves during an earthquake. This wall again acts as a lateral bracings that we call as a strut. That is a diagonal column. Fine, the definition for the strut. So when earthquake comes, this brick resists those earthquake forces and prevent the structural collapse. That's why if you see a building without walls, okay, that will show more drift. उसमें oscillation ज़्यादा होगी. But once you are using walls, the oscillation will get reduced because bricks are there. Bricks increase the stiffness of the structure, and once the stiffness of the structure gets increased, our structure becomes safe. Fine. And you can see here, those openings have been provided. These openings can cause great failure because here we have a diagonal action of this wall. Wall ही नहीं है तो diagonal structure का फंडा ही खत्म हो जाता है और हमारा structure fail हो जा सकता है, and that's the different failure we call as a short column theory. As a separate topic, you can check yourself in your books or in your present online. You can check what is the basically the short column effects. So again, this is the infill which I am showing here. On one side, there's an infill. They act as a diagonal struts, diagonal bracings. And another techniques which we mostly use is that concrete jacketing. Okay, we have the reinforcement. Then on the top of this, we go for concrete jacketing. Our whole structure becomes safe for an earthquake. Like you can see here, the foundation. In the foundation, older concrete has been replaced. We are adding more reinforcement to the foundation. Then we are using concreting. Then we are injecting concrete in it. So by concrete jacketing, we are increasing the structural strength of the foundation. And by this retrofitting technique, we are going to make our structure safe. But again, the disadvantage is that if you will visit some hospital and you will see this type of concrete of that some bandage-like structures, you will say, "ये तो कभी भी fail हो सकता है." But it is seismically safe, but aesthetically it doesn't look nice. It doesn't look beautiful. Fine, structural strength तो हमारी achieve हो गई. हमारा by concrete jacketing हमारा structure safe बन गया. लेकिन if you see with your eyes, you visit hospital, आपको लगेगा bandage ऐसा है तो इसका तो beam ही fail हुआ है. जिस तरह कोई पर्सन चलता है उसके हाथ में प्लास्ट होता है, बाजू ठीक भी होता है, लेकिन हमको लगता है कि हाथ तो टूटा है. फाइन. और इस कंक्रीट जैकेटिंग से अगर किसी का सपोज हाथ टूटा है, हम ऊपर से कंक्रीट जैकेटिंग करते हैं, फिर वही बॉय वही गर्ल उसी जो उसको प्लास्टर होता है उसी से किसी को मारती है तो दूसरे को लगता है. मीन्स बाय प्लास्टर वी हैव इंक्रीज इट स्ट्रेंथ. आर्म की स्ट्रेंथ इंक्रीज हो गई चाहे वो टूटा भी हो. सेम टेक्निक हैज बीन अप्लाइड हियर. द स्ट्रक्चर बिकम सेफ बट aesthetically it was beautiful. किसी को बैंडेज हाथ में जिसने लड़ाई की होगी क्या की होगी, so we don't prefer this type of techniques. Otherwise, for normal structures, ordinary structures, this is a good technique. You can see in the bridge foundation, It is a vertical pier where the bottom he is going for the concrete jacketing, fine, to make the bridge safe for future earthquakes. Now another techniques, that is the seismic base isolation. This is under the category of non-conventional method. We are using bearings at the bottom of a building. So when earthquake occurs, what happens? This force gets generated. Okay, now the force will get transferred to the structure. But what these bearings do, they mobilize, they reduce the earthquake forces. पहले अगर एनर्जी की कुछ लेवल होगी, इन बेयरिंग से आपकी एनर्जी लेवल रिड्यूस होगी, तो बिल्डिंग में लेस फोर्सेस जनरेट हो जाएंगे और उस लेस फोर्स से हमारी बिल्डिंग सेव. But again, we have to check that what should be the strength of bearing, what should be the properties, what should be the damping constant, of what should be the stiffness constant of the bearing. Those we have to calculate, and after we implement forces, what the forces my structure is going to take, fine, what the forces are going to be implemented on the structure, that I have to calculate. These models we can prepare in SAP. We have STAD, various softwares are there. So we can prepare the model of bearings, existing structure, or new structure, because this is for the new structure particularly. So by using these bearings, we can make our structure safe, and that is seismic isolation techniques. तो हमने फोर्स को ही रिड्यूस किया ताकि बिल्डिंग सेफ बन जाए. So non-conventional method. You can see in the bridges में काफी vibrations हो जाती हैं, due to vehicle movement. On vibrations, because vibration is a part of an earthquake. जिस तरह earthquake में vibration होती है, उसी तरह vehicles they create a great impact forces on the bridge piers. What we do, we go for these bearings. Once the bearings we are implementing in our structure, the forces, the generated forces due to vehicle, they get reduced, and my bottom pier, that is the substructure, that becomes safe. Again, it is a non-conventional force को ही हमें reduce कर दिया. This is one of the example of core type bearing. Center में core lead होते हैं, बाहर से this is the laminated, reinforced bearings. इसकी काफी stiffness अच्छी होती है. It has a good stiffness. It resists forces and all those things. Fine. Now we have the supplement damping devices. This is the modern technique where we use damping devices. The damping devices, basically, what is the damping devices? This is a basically viscous damper. Same in case of car. In the olden days, when we were on some vehicle, there were no concept of dampers. My vehicle, it tries to jump on some speed breaker, and the parts gets used to get damaged. So after that, the engineers, mechanical engineers, they introduce the dampers. So अगर आप हमारी vehicle या हमारी motorcycle 30 feet, 20 feet भी ऊपर चली जाती हैं, you have seen the racing motorcycles, stunts and all these things. नीचे आके बाइक को कुछ होता ही नहीं है, because what techniques they have applied, that is the dampers. What basically this damper is? Damper, it consists of a fluid. Fine. Same in case of a vehicle, when vibrations due to speed breaker gets reduced, by way of a tire, they get transferred to the damper. The damper that contains the fluid. Okay, so the energy of shock that gets utilized in sort of in compressing the fluid. Yeah, I will show you this, the sectional view of this damper. So once force gets transferred inside fluid, that passes through an orifice. और बाहर की जो एनर्जी होती है वो बेसिकली यूटिलाइज होती है कंप्रेसिंग ऑफ फ्लूइड में. फ्लूइड हीट अप हो जाता है, लेकिन जो हमारी व्हीकल है उस तक कम फोर्सेस ट्रांसफर हो जाते हैं. तो वी हैव मेंटेन द लॉ ऑफ कंजर्वेशन ऑफ एनर्जी, दैट एनर्जी कैन नीदर बी क्रिएटेड नॉट destroyed, or we can transfer it from one form to another form. So vibration forces I have transferred to the damper, it has transferred to the fluid fluid got transferred to the orifice, it got compressed, energy, heat energy has produced in the fluid, so my energy got reduced, it got wasted, and my vehicle has not been affected, has not got affected due to those forces. Less forces vehicle तक पहुंचे. तो पहले ही मैंने इनको reduce किया by using the damper. Okay, and I have maintained the law of conservation of energy also. Same techniques we apply in the buildings also. We use these type of dampers, those viscous dampers, or just what basically these dampers. You can see this is a line model have been created in the SAP. You can see these dampers have been introduced here. पहले स्ट्रक्चर में हमने डैम्पर डाल दिए, उसमें हमने देखी फिर forces. Okay, forces we have applied. Then what we have seen, the structure which is having the dampers, fine, it drifts less. Definitely when your top drift, suppose x is less, your F force, that is the multiple factor of K into X, okay, stiffness into X. Once X gets reduced, your force gets reduced. It means the internal forces or the reactive forces, they get reduced. Column B में कम force आ जाएंगे और हमारा structure safe रहेगा. Now in the structure, why we don't have the dampers? We are applying the earthquake forces, fine. So they get transferred. Top drift X, that will be more. Now the force will be is the multiple of K into X. K is the stiffness constant. X is the top drift of structure. So once top drift that gets is more. So X is more, F is more. So more forces gets generated in the beams, columns, and my structure may fail. So these dampers reduce the drift of structure. How they reduce the drift? By way of dampers, which contains the oil. So earth forces, they get utilized in compressing of fluid, heat energy gets generated, my all earthquake energy gets wasted, and my structure that faces less forces. Okay, that's a technique how we can make our structure safe by using dampers, and this is the good technique what should be implemented in the Gibbon Hospital, because dampers is the best solution. And earlier I have explained why I have not applied the techniques of shear walls, concrete jacketing, bracings. So for any existing structures, you have to go for proper analysis. Maybe shear wall will be good, maybe bracings may be good, maybe concrete jacketing may be good, but we have to see the overall response of structure after that by using the model, by using the computer. Okay, after that you can give your suggestions, whether shear wall, whether concrete jacketing, whether bracings, whether dampers. So I have implemented dampers in the structure. You can check for other forces also. We can use bracings in the GP England Hospital, and you can check it. I have checked that what failed, but you can check it. You can recheck me. You can give your own suggestions. So this was the topic, how to make our structures safe for earthquake. Thank you very much. Thank you.
Okay, सर आप ये शेयरिंग स्क्रीन मुझे वापस हैंड ओवर कीजिए. Sir, actually, okay, thank you, sir. Thank you, sir. It was really a wonderful presentation, and I'm sure that it must have added knowledge to our students. As I have received feedback from students in our chat box, there are some queries that students want to know about. I request you, sir, to address these queries one by one. अब मैं लूँगी कुछ students. Okay, sir. Okay, sir. Let me share. Sir, you are not audible. You are not audible, sir.
Yeah, I'm looking your voice.
Yes, sir. Okay, sir. There are many students. Okay.
Right. Yeah, carry on. I'm getting.
Okay, sir. Here is the student Irfan Shah. He want to know. वो बताना चाह रहा है कि using more metal rods in columns and horizontal rows of a building, will not that building be more prone to lightning?
Pardon, please repeat the question.
Okay, using more metal rods in columns and horizontal rows of a building, will not that building be more prone to lightning?
Right, I'm getting.
Sir, आप इसके साथ live answer कर सकते हैं. Wait a minute. Okay.
His name is
Irfan, आप अपना question डाल सकते हो. Yes, Irfan, are you audible? Yes, Irfan. Sir, आप इसको ऐसे ही पूछिए अब. Okay. Which column is better, cylindrical or cuboidal?
He can call me on the phone. Just share my contact number. He can ask me question here on the phone, because that will be more audible.
Okay, sir. दूसरा student है जिब्रान नकाश, बोल रहा है कि the hospitals can't be reconstructed or anyway mode earthquake resistant. There still has to be a way to do so.
The first person has he got the answer?
Yes, sir.
Basically, so what he's saying that if we, I will continue. Are you getting my voice?
Yes, yes, sir. Yes, sir. ये बता रहा है
Basically,
कि
what
okay, sir. Continue, sir.
is he getting? Is he getting my voice?
Yes, yes, he's getting.
Fine. What
Yes,
happens
yes.
basically if we add more vertical rods in the column? Fine. We will increase the bars as compared to beam. What happens? It will make strong column, weak beam theory.
Yes, yes,
Okay,
exactly,
that's
sir.
a good suggestion. Fine.
Yes, yes.
Because we prefer that if an earthquake or a failure or the mechanism will occur in a structure, fine. First our beam should fail. Okay, अगर beam fail हो रहा है, we will get enough alarming chance to escape. हम भाग सकते हैं building से, अपने आप को बचा सकते हैं. Fine. But if we make our column weak and beam strong, what happens? Our column will fail first. It is
Okay,
same
sir.
that someone is pulling your leg. Okay,
Okay, sir.
abruptly you will collapse. Same if our column is weak, my structure will collapse abruptly. The people inside, the occupants, will not get enough alarming chance to escape. So we prefer a weak beam and a strong column theory. Fine.
Thank you, sir. Thank you so much. तो एक और student है यहाँ पर, sir. Let me take a question. Zainab Ramzan, why population is the main reason for earthquake? Why population
Yeah,
is
again,
the
please repeat the question.
yes? Why population is the main reason for earthquake? Population क्या main क्यों main reason है earthquake के लिए?
I got the answer of this candidate. Basically, what happens? You know, one of the earthquake I said that sliding occurs. Fine. Due to increase in the number of population, we have gone for the deforestation. We used to cut the trees and all these things. What happened? The sliding of you know, avalanche prone areas, or we have some areas where the landsliding occurs. So once the landslide occurs, definitely it will produce some forces. It will produce vibrations, and that vibration gets reduced, gets transferred to the earth, and it causes the earthquake. So increase in population, more deforestation, more sliding, more earthquake.
Definitely, sir. Definitely. Thank you so much, sir. Hope the student got her question. Sir, एक और student है Zaira Hussain, section E. Is earthquake prediction possible? Is earthquake prediction possible? Simple question.
You know, till day we can never predict the earthquake. It is all in the hands of Allah, you know.
Yes, yes, exactly.
The Almighty Allah, He has kept some control on us. We never come to know about the earthquakes. However, there are, you know, seismic centers. What do they basically check? They check the occurrence of seismic forces. किसी area में seismic zone, like in Kashmir, in Gulmarg, suppose we have the seismic center, they check the vibrations in the ground. Fine. Okay, they can intimate us that earthquake may occur, but in real sense, we never come to know when the earthquake, at which time it will occur. So we have to be always, you know, obliged with Allah. Thank you.
Thank you, sir. Sir, एक और question है Muntazir Ali from section E. Sir, how many places we can use vibration control device, namely dampers? How many places? Sir, you got the question?
I want to confirm again, please.
Okay, sir. How many places we can use vibration control device?
Places.
Yes.
We have structures like buildings. In the buildings at the corners, which will not disturb the movement of public. You know, I have shown the photographic view of also that on, you know, external walls, we can use these bracing in buildings. In bridges, we can also use the dampers. Okay, we have the beam, steel beam at the bottom. We can connect with the pier. Vibration will occur. This damper will reduce the forces, and less forces will get transferred to the pier, and we can make our bridge also safe for earthquake. So buildings, bridges, vehicles, anywhere we can use these dampers.
Sir, one more question. Kafil from section A, civil. What kind of material is used in shear walls? Shear walls में हम कौन सा material use कर सकते हैं?
We have different materials. In case of a steel structure, fine, we can use steel type of vertical shear wall. Okay, steel का structure है, वहाँ पे steel का ही हम plate डालेंगे shear wall. अच्छी strength का जो design है, recommend करे, designer recommend करे. दूसरा point है कि in case of RCC building, we can use RCC shear walls, which contains the reinforcement and concrete. Fine. And in case of a timber structure, we can also use timber type of shear wall, plyboard having good strength to prevent its lateral drift, to make it safe for earthquake. So as for the building, we can use the shear wall of a desired material of, you know, it should be matching.
Thank you, sir. एक और अटेंडी है यहाँ पर, बट इसका नाम नहीं है यहाँ पर, तो सॉरी टू से मैं आपका क्वेश्चन नहीं ले सकती हूँ, क्योंकि आई हैव ऑलरेडी इंस्ट्रक्टेड कि आपको प्रॉपर नाम विद प्रॉपर एनरोल आना चाहिए, इसलिए आपका क्वेश्चन मैं नहीं ले सकती हूँ, सॉरी टू से।
No, if he has asked some question, name doesn't matter because some people are unaware about this system. मुझे भी खुद प्रॉब्लम हो रही थी इसको because
So you want to take his question, sir?
Yeah, you can continue questions. अब किसी को दिल
Okay, sir.
दुखेगा,
So
it's
he
not
is
good.
saying anonymous कुछ attendee है. He is saying what is the difference between the magnitude and the intensity of an earthquake? What is the difference between the magnitude and intensity of an earthquake? Magnitude और intensity में क्या फर्क है?
What my, that I have already explained.
Yes, sir.
Again, I will repeat.
Yes,
Magnitude
yes,
determines the energy of an earthquake. It defines the area on which the earthquake has occurred. More magnitude means more energy, but it doesn't mean the more damage. Intensity, that means the damage. Fine. More intensity means more damage. If again I will explain, the earthquake of magnitude 5 will occur in Lal Chowk and 9 will occur in Kargil. As per simple logic, you will say 9 will create more damage. No. In Lal Chowk, your magnitude 5 can cause more damage because density population is more there. ज़्यादा लोग मर जाएंगे. कारगिल में कुछ घर है, उतने नहीं मरेंगे. So that is the magnitude. But
Hope
intensity, when I will
student
say
got his
intensity is
question.
more, means casualties are more.
सही बात सर। एक और स्टूडेंट है यहाँ पर, तैयबा कोल है यहाँ पर, इसने बड़ा लंबा चौड़ा लिखा है, मैं थोड़ा सा इसको पढ़ लेती हूँ। Construction of earthquake resistant buildings is costly, and you said that there was a way that we could reduce the intensity of the earthquake. Is there a way we could reduce the cost and simultaneously reduce the intensity? क्या ऐसा कोई तरीका है कि हम simultaneously reduce cost भी कर सकते हैं और intensity भी reduce कर सकते हैं?
Yeah, definitely. If I am going to make any structure seismically safe, okay. First, what I will do, I will prepare a proper model in my STAD or any software. Then I will apply different techniques, bracing system, other systems, okay. After that, I can go for the cost analysis. अगर मैं shear wall use कर रहा हूँ, मेरा cost of building कितना बढ़ेगा? अगर मैं dampers कितना? After that, I give my suggestion. But final suggestion should be on safety. ये नहीं कि कुछ पैसे बचेंगे तो हम lower technique करेंगे, कल को building collapse लोग मर जाएंगे. So important is we should give importance to the safety of people. Fine. Okay. For that we have to go for a proper analysis. जो analysis हमें अच्छी लगे, economical but safe. Fine. We can apply that to our structure. That's why we have to go for a number of analysis procedures. Fine.
So one last question we will take. One last question is from Faik Manzoor. If the magnitude of earthquake is above 8 or on Richter scale, what will these modern techniques withstand the earthquake force? If the magnitude, I will repeat, sir. If the magnitude
definitely.
of, if the magnitude
I got.
Okay, sir. If you want, no problem.
Fine. Basically, if magnitude is 8, okay, we can design any damn thing. Being an engineer, we can see the past time history analysis. Like Bhuj earthquake, Muzaffarabad earthquake, I can calculate the past or devastating earthquakes. Like जो Muzaffarabad में earthquake हुआ, there is no less chances it may occur, or there are more chances it may occur. We are not, sure about an earthquake, what will be the future earthquake. So for any magnitude, we can design our structure, but it will be economically, it will be uneconomical. आपको स्ट्रक्चर रेजिडेंशियल हाउस, आपको जेब में कुछ पैसे हैं, बैंक में कुछ पैसे हैं, 50-60 लाख, मैं आपको हायर टेक्निक्स बनाऊंगा फॉर 8 के लिए, जबकि 8 को आ भी सकते हैं, नहीं भी आ सकते हैं. फाइन. तो ऐसा नहीं मैं आपको बोलूंगा 10 करोड़ लगेंगे बाय मेकिंग योर स्ट्रक्चर सेफ फॉर 8, तो आप भाग ही जाओगे, क्लाइंट ही भाग जाएगा मुझसे. ठीक है. तो वी कैन डिजाइन फॉर 8 मैग्नीट्यूड आल्सो, बट आवर स्ट्रक्चर मे बी विल बी अनसेफ. नाउ व्हाट वी डू, देयर आर टेक्निक्स. फाइन. So you are saying, yeah, I have less money in my pocket, in my bank. Do something. It should be safe for 8 magnitude earthquake. Okay. At the same time, it should be economical also. Fine.
Sir, one thing I would like to say to the students that उनको मैंने बताया था आपका जो क्वेश्चन करना है Q and Q करके, तो चैट बॉक्स में जिन्होंने क्वेश्चन लिखा, it's all mess. We can't read it properly because बहुत सारे स्टूडेंट्स ने क्वेश्चन किया है. तो क्यों में आपको क्वेश्चन करना था. ठीक है, तो कोई मसला नहीं. इंशाल्लाह नेक्स्ट टाइम इंशाल्लाह हम प्रैक्टिकली इस वेबिनार को फिर से करेंगे जब कॉलेज खुल जाएगा. ठीक है, तो expert.
I want to continue. I want
Yes,
to
yes, sir.
continue.
Yes, sir.
I'm not going to conclude. Just wait. So if we have to make our structure, resistant for an 8 magnitude, cost will be high. So better is to go for ductile detailing. Ductile detailing means that I will design my structure in such a way, my columns, my beam, my slab, that should be ductile. What ductile means that if a failure will occur, okay, building को तो 8 पे fail होना ही होना है, because it should show the mechanism type of failure. It should give enough alarming chance. The structural failure that should not be brittle. अगर structural collapse होगा भी तो धीरे धीरे, अगर 8 magnitude structural collapse होगा भी, it should show a mechanism such that people should get a chance to escape. Now for designing 8 magnitude, you can see in the Japan, lot of devastating activities have occurred in the Japan, having the high-rise buildings, very tall building, 150, 200-story structures. What presently they are using new techniques, okay? And when the earthquake comes, they are enjoying the vibration of earthquake because they know they are safe. They are using high techniques. So any damn thing can design, but it will be uneconomical. Okay.
Sir, students, we are organizing the seminar at college to address all your queries. Due to time limit, we can't address all the queries. So I would like to express our gratitude to Engineer Mueed Rasool on behalf of my department, Applied Science and Humanities. And I'm sure in future, your support will remain with us. With this positive note, I would like to, I conclude today's webinar. Allah Hafiz everyone.
Thank you. It's a blessing for, I wish to, I pray for all that Allah give them a good health, and
thank you, sir.
May Allah shine them, and Allah may give them the bright career, the bright future. And one of the only the what basically message I want to convey them: if you are working as an engineer, you have the time at this time to study properly. It is just a matter of few years, 4 years after the MTech of 2 years, 6 years, just matter of few days, okay? But utilize your time in a proper way, use your money in a proper way. So definitely you will shine, and a time will come you can earn as per your choice, and you will be a future and bright engineers in the future. Thank you.
Thank you, sir. Thank you, sir. Thank you very much, students. And मैं आपको सर की email ID सेंड करूंगी, तो आप अपना जो क्वेश्चन है, जिनको टाइम नहीं मिला, जिन पर हमारा ये ध्यान नहीं पड़ा, तो वो सर से फिर पूछ सकते हैं email ID से. Thank you so much, sir. Thank you so much, students.
The WhatsApp number.
Yes, sir. Can they WhatsApp you?
Yeah, because that is much better, because I don't prefer to use the email every time. WhatsApp पे तो हाथ ही होता है दिन भर.
Okay, sir. Thank you so much. Thank you so much for your valuable presentation, and thank you, students, for your active cooperation. Thank you so much. Allah Hafiz, everyone.
Shall I conclude?
Yes, sir. Yes, sir. Definitely.